Hello everyone and welcome back to my channel. Today we will see some numericals on theories of failure. In last video we learned what are the different types of failure, what is cause of failure. So the cause of failure, first we will see a small revision what is failure. So if material is fail, then why it fail? It may be because of material properties or because of the stresses acting on that particular body. So there are different five theories of failure. Theories of failure we learned in last videos. Today we will see one numerical and we will see whether the material will fail or not. I will consider a single example, single numerical, and I will check whether that material will fail or not. Clear? So let's start with this numerical. First, I will read the numerical. The principal stresses at a point in elastic material 200 Newton per mm square. So given data, I will consider here given data. Now sigma 1 is given, that is 200 Newton per mm square, its tensile. Second, sigma 2 is given, it is 100 Newton per mm square, and sigma 3 is also given and its value is minus 50 Newton per mm square. Why I am taking minus? Here all are plus because these two were the tensile and this one is a compressive. So if the stress at elastic limit, so stress at elastic limit in simple tension is given, so that is sigma t star is given, it is equal to 200 Newton per mm square. Clear? So first we will see what is failure. Failure may be happen because of the material properties or stresses on the system. So failure is nothing but deformation of body beyond elastic limit. Are you getting my point? So the body may be brittle or body may be a ductile. In that, if you observe, there is a elastic limit point where stress is up to that point stress is directly proportional to the strain. Once you remove the force or stress at that point, then again that body will regain its original shape and size. However, after that, beyond that point or on that particular point, if you observe, after yielding will start. If it is a ductile material, then it is called as a failure of that material. Before fracture, whether the failure of material will take place, answer is yes, because in ductile material, if you observe the stress strain curve, then be, before fracture, material will go for the plastic deformation. That point, after elastic limit, any point of the stress is called as a failure of that particular material. Now in given data, there are three force sorry there are three stress are acting on particular body, and a simple tension force is given up to the elastic limit, and one is given 0.3, Poisson's ratio is given 0.3. Clear? So if you're not imagining this stress system, then you can refer our previous video. So here, if you observe, sigma 1 is along x direction, sigma 2 is along y direction, and sigma 3 is along z direction, and it is compressive. Clear? Now we will see how whether the material will fail or not by using the different theories of failure. So first I will consider, we will see one by one. First, Here we consider the maximum principal stress theory. Maximum principal stress theory. Clear? Now here we have considered the some assumptions, that is sigma 1 is greater than sigma 2. So in this problem statement, whether sigma 1 is greater than sigma 2, yes, sigma 1 is greater than sigma 2. And here what we have considered, sigma 3 is compressive. So while explanation, I already I have already informed you that sigma 1 is greater than sigma 2. Clear? So in that case, when the material will fail, the condition was sigma 1 must be greater than or equal to sigma t star, or compressive stress must be equal to or greater than compressive stress up to the elastic limit. We cannot check this condition as the value of sigma c star is not given, that is stress in compression up to the elastic limit is not given. However, we can check the first condition. So if you observe this, then we get sigma 1 is 200 and it is equal to the sigma t star, it is again 200. So from this can we say material is fail. So failure of material will occur. Clear? So this was the first case in which we observe when sigma 1 is greater than or equal to sigma t, then definitely failure will occur. Simple. So second is maximum principal strain theory. So we will see the second case. I am using the same formula, sorry, same uh, numericals. So second is maximum principal strain theory. So I am using same input. So if you look at this particular case, maximum principal strain theory, in which we evaluated the formulas, and from that we get the different equation. So let's consider this equation, 1 upon e sigma 1 minus mu into sigma 2 plus sigma 3, it must be equal to or greater than sigma t star divided by e. So this is strain along one direction. We can evaluate strain along all these three direction. Clear? So let's see how it comes. So I will write for strain along one direction, that is small e1 equal to 1 upon e in bracket sigma 1 minus mu into sigma 2 plus sigma 3. So it will come, we don't know the e value, so I will keep as it is. Sigma 1 is 200 minus mu into sigma 2 is 100. Am I right? Yes. And sigma 3 is 50. So let's start. 1 by e equal to 200 minus 0.3, mu value is given, so it is 50. So if you multiply 50, then it will comes 185 divided by e, that is sigma, sorry, that is strain along the x direction. So what is the case? We must find the e star also. Clear? So that is strain up to the elastic limit. So that will be the sigma t star divided by E. How much sigma t star? It is 200 divided by E. Now from equation 1 and 2, if you observe, 185 divided by E is less than 200 divided by E. So E will remain constant as material are same. So from this conclusion came that failure will not occur. Clear? So failure will not occur according to this maximum principal strain theory. Is that clear? However, material will definitely fail according to maximum principal stress theory. That's why in previous video I already explained important points or conclusion that some of the theories are used in specific conditions only. Clear? So which theory we must use, that must be important. Sometimes you may think that material will not fail. However, failure will occur because of the maximum principal stress theory. Even though this theory is not showing, but it will not applicable in case of this particular problem statement. Clear? So if brittle material is there, at the time you must use principal stress theory. One masses distortion or energy distortion theory is very important for the ductile material. Clear? So from these two also we can conclude that all these theories are made for specific conditions only, for specific materials only. In next year there is a machine design. In that case you must consider a proper theory for the material. Clear? So I hope you understand from this equation which theory we must use for the different application. Clear? So let's see the next theory, that is maximum shear stress theory. Maximum shear stress theory. So what is maximum shear stress theory? How we can evaluate the maximum stress? That it can be evaluated by using the formula sigma 1 minus sigma 3 divided by 2. So this is nothing but maximum value in the stress system, and this one is the minimum value in the stress system. So this is maximum shear stress. Clear? So in this problem statement, what is the maximum value? It is 200 minus, so this value is minus 50. Clear? Divided by 2. So it is nearly about 125 Newton per mm square. Is that clear? Now we need to check for up to the elastic limit. Clear? So here maximum shear stress up to elastic limit. Now up to elastic limit there is one tensile stress, then 0 and 0, because there is no other stresses are present. Clear? So I can evaluate maximum principal stress, sorry, maximum shear stress up to elastic limit by using this formula minus 0, as minimum value of stress is 0 divided by 2, sorry. So here 200 minus 0 divided by 2, it is very simple, 100 Newton per mm square. So from these two equation, sorry, I can conclude that the value of 125 is greater than 100 Newton per mm square. So maximum shear stress in this particular system is greater than maximum shear stress up to the elastic limit, or in simple test. Sorry. So from this, can I conclude? Yes, definitely failure will occur. So from this test also, sorry, max, maximum shear stress criteria, we can say that material will fail in this particular stress system. So this is our this third theories of failure. Next theory what we learn, that is maximum strain energy theory. So let's see what is that maximum strain energy theory. So let's check through that theory also. So fourth number, maximum strain energy theory. So let's check through this principal stress equation. So from this we can evaluate the total strain energy per unit volume. Clear? So that equation we were developed over here, maximum strain energy per unit volume. So here is the equation. So there are three stresses are there, and we can evaluate maximum stress using this equation. Clear? So I will rewrite that equation. 1 upon 2e equal to sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 mu into sigma 1 into sigma 2 plus sigma 2 into sigma 3 plus sigma 3 into sigma 1. So this is the equation. Clear? I will just put all the information over here. 2e bracket 200 square plus sigma 2 is how much? Sigma 2 is 100. So 100 square plus minus 50 square minus, this is another bracket, 2 mu, that is 0 0.3, 2 into 0 0.3, 100 into 200 into 100 plus, this is 100 into minus 50, just check the brackets, sigma 3 is minus 50 into sigma 1 is 200. Yeah? If you solve this entire equation, then you will get 1 upon 2e into 49500. Just check it whether these values will come or not. Now we can evaluate total strain energy per unit volume, total strain energy per unit volume up to elastic limit. Clear? So same formula will be there which we have already derived. So here if you observe, so it is 1 upon 2e sigma t star whole square. So 1 upon 2e into sigma t star square. So it is 1 upon 2e into, it is given 200 square. So if you consider 200 square, then it will come near, come to 40,000. divided by 2E. Clear? Now from these two equation, let's say this is equation number A and let's say this is B. So I can say that this value is greater than this value. So from this theories also we can say that failure will occur. Clear? Simple. So with this we learn the different from four theories. We can say that the failure will occur. Now let's see the last one, that is maximum shear strain energy theory. Maximum shear fifth one, maximum shear strain energy theory. Maximum shear strain energy theory, or this is also called as a one meshes theory, maximum distortion energy theory. So this is the generally we use theory for the ductile material. Let's see what is the equation, that is total shear strain energy per unit volume due to principal stresses, that is sigma 1, sigma 2 and sigma 3 in stress material, that can be evaluated from this equation, that is 12C into in bracket sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. Clear? So just put the all value 12C into sigma 1 is 200 minus 100 whole square plus 100 minus minus 50 whole square plus minus 50 minus sigma 1 is 200 whole square. Clear? So this value will be near about 95,000 divided by 12C. Let's say this is equation C. Similarly, we will evaluate total shear strain energy per unit volume due to up to the elastic limit. Clear? So that equation we already evaluated. So I will rewrite that equation over here. That is total shear strain energy up to elastic limit, or we can say due to the stress sigma t star. Clear? So it is 1 upon 12C into 2 into sigma t square. Clear? So if you put the value 12C into 2 into 200 square, so 200 square is 40,000 and into 2, so it is near about, it is 80,000 divided by 12C. So let's say it's equation D. Now from these two equation, from equation C and D, I can conclude that this value is greater than this one. Clear? So from this I can write failure will occur. Simple. So we already seen how the different stress energy theories are applicable for same formula. However, from this equation or from this theory we concluded that failure will not occur. Clear? Remaining four theories are saying that failure will occur. Definitely from one equation also, sorry, from any one of the theories saying failure will occur, then definitely failure will occur. So for different conditions, different material, different loading condition, we may consider the different theories of failure. Clear? Now you may ask me, sir, why all the times system will not fail? Because if you observe different automobile sector, we have piston cylinder alignment, we use car or motorbike for 15 years, more than that. Clear? Still why failure will not occur? Because while designing we consider the permissible weight, permissible stress value. Clear? So this, what is this permissible stress value? That is a sigma t, and it is equal to sigma t star divided by factor of safety. So this factor is very very important, and if you consider for the aerospace and all, here we increase the factor of safety. Clear? Now due to this factor of safety, we design entire system on this sigma t. So obviously if I consider factor of safety is 2, and if I consider the same numerical, then I will design entire system on sigma t equal to 100 Newton per mm square. Clear? And this value I will check with the different theories of failure. Clear? And in this particular case, if the material will failure will takes place, then definitely your system will fail. Clear? As we have taken factor of safety equal to 2, you may increase if the precise instrument is there or it is used for a different application. In that case we will vary the factor of safety, and that is the only reason we never observe the failure of system. Sometimes if you have not considered the deterioration of material, that also we need to consider. So more information or more detailed knowledge you will get in machine design subject, where you may check the different conditions, different loading conditions, different material properties. In that case failure may occurs by different parameter. Clear? So I hope you understand a simple numerical and these theories of failure. If you like this video, then you can subscribe the channel. Thank you so much.